My name is Ben Shamgochian, and I'm a forest ecologist with Our Climate Common. Today I'm here to show you how to do the Rapid Assessment Protocol, which we call the RAP, which is a protocol that we've developed for foresters or any ecologists or any other interested parties to quickly and easily identify late successional and old growth forests in the field. So this Rapid Assessment Protocol came out of our 2024 work, in which we mapped late successional and old growth forests across all of northern Maine using LiDAR data. Now, LiDAR data is a kind of remote sensing data which picks up on tree heights, and you can use it to model the structure found in late successional and old forest. So we use that to predict where we thought late successional old growth forest is in northern Maine. This model, through field validation, has turned out to be really accurate, about 90% accurate in telling late successional and old growth forests from younger forest classes. Even so, making any management decision is going to be costly to a owner. And we want to be sure that what we say it is what it actually is on the ground. So to that end, we built a rapid assessment protocol in which users can go out and go to visit these likely LSOG stands on the ground and see what they really are. And that's the protocol I'll be explaining today. So what you're looking at here is the LiDAR canopy height model. And this is that height model that I just discussed. So the colors here symbolize different heights, with the magentas and the blues symbolizing higher tree heights, and the yellows and the oranges and blacks symbolizing lower tree heights. This grid that you see here is a hectare grid, which is the sampling unit of both the LSOG map and the Rapid Assessment Protocol. In this scene, the blue dot here is where we are currently. And the goal of this RAP is to figure out what the classification of this hectare we're standing in is. The magenta color here indicates that the 2024 model predicted this hectare to be old growth, and we're running to test if that is accurate. The other colors you see here are the other of the four classes. We have not LS, transitioning LS, and late successional. To cover this hectare systematically, we're going to walk a rough transect line, which transcribes a 50 by 50 meter square within the larger hectare. And this will allow us to see all areas of the hectare without having to walk every single square meter. This transect doesn't have to be exact. You don't need to lay out any lines or measuring tapes. But you should, keep an eye on where you are if you have a hectare grid, or if you don't, really be careful about estimating how far you've walked. To walk this transect, what we're going to do is start in the center. We're going to walk north 25 meters. From there, we'll walk east 25 meters, walk south 50 meters, walk west 50 meters, walk north 50 meters, walk east 25 more meters, and then we can return back to the center of the hectare. We've chosen this rough coverage of a hectare for efficiency, so that someone could do multiple of these in one stand. And that's what we recommend. Every hectare is independently classified, so if you're able to collect multiple samples in a stand, you'll be able to get a better result. This is the data sheet we've built that you might want to use when you're conducting the rapid assessment. This datasheet gives you all of the 17 metrics you'll be looking at. It provides you tally boxes to help you keep track of things as you go, and a section for notes. So here on the left side of the page, you can see the blue boxes, and each blue box relates to one of the 17 metrics. And as you go, some of these are just presence absent. So if you see something like stump sprouts, all you have to do is check off present, and then you can forget about that metric and focus on the other 16. Other of these metrics are tallies of number of trees greater than 40 centimeters or number of downed logs greater than 40 centimeters. And as you go, you'll want to be tallying these. And it's for ease, you can do this on paper, and we've provided you some boxes to put your tallies in. And once you've finished the rapid assessment protocol, you're just going to tally those up and select the number of trees that you got. One thing we recommend people doing is flagging a tree at the center of the hectare And this is just useful so that you can keep an eye on where you are as you go. And you'll be keeping an eye on the compass, and if you have a hectare grid, the hectare grid. But this will just help you also keep situated. So I'm going to take you with me now to run this RAP, and I'll show you all of the things we're looking at. So I've got my compass here on my phone, I've got my hectare grid, and I've got my data sheet. One of the key metrics in the RAP is the number of 40 centimeter large diameter trees. 40 centimeters is also 16 inches, so you can use whichever you're comfortable with. It can be hard to know a 40 centimeter or 16 inch tree when you see it. If you've measured 10,000 trees in your life, you might be able to do it without any measuring tapes. But it's good at the start of every RAP to just, give yourself a benchmark of what a 40 centimeter tree looks like in this stand. So it's good to have with you DBH tape or a Biltmore stick or some tree calipers to quickly check a couple trees, especially if they look close to 40 centimeters.
That's good.
So this here is a 64 centimeter tree. So we'll tally this as one tree. If you don't have a DBH tape, you can easily make your own measuring stick. See here, we've marked out 40 centimeters on this walking stick, and you can use that as a quick reference to see if your tree is over or under 40. Another metric we have users pick up on are the number of 40 centimeter or larger standing dead trees, like this snag right here. This tree is clearly over 40 centimeters, so we'll put down one tally. For all of the tallied metrics, it's important to keep an eye on where you are in the hectare so that you don't double count things. So what I do is when I start at the center, I can first look around to see if I have over 20 40 centimeter trees, which is often the case in a old growth or late successional forest. But if I don't, I'll start from scratch, and as I walk the transect, I'm going to tally all of the trees as I go, so I'm careful not to double count them. And this also holds true for logs and standing dead snags. Behind me is a large tree that's fallen. Another metric that we use in this RAP is large canopy gaps. And you can see that this tree created this large gap up here. This variable is presence absent, so if you see one of these, a large canopy gap, you can check it off and keep going. Another metric that we're having users collect is the number of large 40 centimeter or greater logs. This one here is over 40 centimeters, so we'll tally it. So you might not be able to see it too clearly in this video with the thick understory right here. But I'm standing right now in a pit with an adjacent mound, and this is one of the metrics we pick up on pit and mound microtopography. And throughout a forest, if you can see it, it's a lot easier to see in person. This creates an undulating forest floor. And now what creates this structure is a large tree fall gap, like we just looked at. Those large tree falls, the roots, as they go over, will pick up a lot of soil, and that creates this pit that I'm standing in. And as the roots, which would be up here with the tree facing that way, as the roots decay, they're going to drop all of that soil right here. And these structures can last on the forest floor for hundreds of years. This structure is characteristic of older forests because it indicates that the process of tree fall gaps, and especially large tree fall gaps, has been happening continuously for a very long time. Now, another metric that we collect is if you see recruitment of species that you find in the overstory and the understory. And the reason that we collect this metric is that it's indicative of a steady state forest. The forest isn't transitioning from, shade intolerant species to shade tolerance. It's been in a steady state system for a while if it has recruitment of the overstory species and the understory. So here we're standing in a sugar maple forest, as you can see up there. And down here, we see sugar maple regen in the understory. If you see the recruitment of the same species in the overstory as the understory, you can check this metric off in your RAP. Now, something that's indicative that the forest has somewhat recently gone through a heavy disturbance is if you find shade-intolerant species in the overstory. Now, a shade-intolerant species of tree is something like a quaking aspen or a big-tooth aspen or a red maple. And these are species that do really well with a lot of light. So if there was a lot of clearing, if there was a lot of light coming down to the forest floor, those species are able to colonize that area and compete really well. And that indicates to us that this forest has had a lot of light in recent times. Here, in this old-growth forest, we aren't finding any shade intolerance in the overstory. When you're running the RAP, you're going to count the number of individuals of shade intolerance. You'll tally those up in one of the boxes. And at the end, you'll just sum up your tally and record how many you saw. Another metric that we have users collect is if they find stump sprouts in the stand. And this is an indicator that a tree might have recently been cut in this area. A stump sprout is often formed in red maple trees or occasionally sugar maple trees. And when you cut the tree will send up a flush of small saplings, which will grow to form trees. And these will form in a ring around that cut stump. Because we're not finding any stump sprouts in this hectare, it's an indicator that there might not have been recent harvest here. Two more metrics that we have users collect on harvest history of the stand are if they find sawn stumps or skid trails. We're not finding any here, because this is an old-growth forest, but a sawn stump is pretty easy to identify if it's fresh. You'll see a stump from about a foot high to sometimes up to chest height with a flat top. Now, as these degrade, it kind of flakes apart and it's a little harder to tell if there's a flat top on it. If you see a bunch nearby, it's often an indicator that they went in and cut a bunch of trees right there. So you can use the frequency of them to identify whether you think it was a sawn stump. For those older sawn stumps that you're not quite sure about, you should also look around really carefully to see if there's any old logs that could have been associated with those. And if you find those, it's probably an indicator that that wasn't cut and that it fell down naturally. Skid trails are sometimes hard to spot in a forest, especially if it's been a long time since the harvest happened. Now, the skid trails are where they, brought their machinery in or their mule to pull out logs. And if it's fresh, you'll see it as an actual, corridor between the trees. If it's been a longer time since the harvest, you might see a skid trail as a bunch of smaller trees in a line. So you could look one way and look the other way. And if you see an area with, some smaller trees, whips and poles about that big or a little bigger, and no large trees in that path, it might be an indicator that that was an old skid trail. Now, we're not finding any skid trails or sawn stumps here because this is an old-growth forest. Another structure that is sometimes found in older forests but is pretty uncommon in younger forests are finding large canopy trees that have had part of the top fall out and are still alive. And this often happens in high wind events, and you'll often find this in hardwood trees like sugar maples or yellow birch. Up here, we see a sugar maple whose top has broken out and it's still alive. You'll often identify these not by seeing the top like that, but by finding a top lying on the ground, and you can look up and see if the tree is still alive. If the tree is dead and has a broken out top, that doesn't count for this metric. So to conduct the RAP, we ask users to learn to identify 5 easy-to-identify epiphytes that are often found in older forests. Here's one of them. This is called Labaria quercusans. It's this kind of light blue lichen right here. This lichen is one that lies flat against trunks of trees, usually hardwoods, often sugar maples. And it's dry right now, so these are kind of faded. They're usually a much brighter shade of blue. And the way to identify it from similar lichens is the fact that they've got these rusty little cups here, right there. And those are called apothecium in the science community. And that is diagnostic of this species. They're often very large like this and will form kind of round features on a tree. on the same tree, we found two other of our epiphytes that we look at. So down here is a kind of moss. It's called Necra pinnata. And you can see that it's got this really brushy texture. And the fronds often form shelves here. Each frond will have these little leaflets that come out to the side. Now these are pretty similar to another epiphyte that we look at, which is a liverwort. And these are very closely related to mosses. And you can see that they have a similar structure, but the texture is very different. They kind of have a scaly, like a chicken foot texture and a little bit of a chicken foot structure there. And these two are often found together, and they're associated with older forests. Another epiphyte that we ask users to identify is called Liberia pulmonaria. And this is a type of lichen that's often found on hardwood trees like this sugar maple here. Here it is. It forms these large bushes on the sides of trees, and the leaflets kind of look like oak leaves, and they've got this vein structure here. Now, when they're dry, they can look kind of grayish like that, but when they're wet, they get really a vibrant green color like this. Another epiphyte that we ask users to identify is called Bryoria. Bryoria is often found in older softwood stands, so we didn't find any in this old hardwood forest. You can identify Bryoria from the similar usnea, which is often also found on softwoods, by the fact that Bryoria is often a lot wispier. They're both very thin, and Bryoria is a very fine strand. It's also a lot darker in color than the lighter green usnea. Bryoria is one of the most difficult to find of these 5 epiphytes that we ask people to identify. It's very small and wispy, and it kind of blends in against the brown bark of a tree. One of the easiest ways to find them is if you're looking at a softwood. If you actually get lower and you look up the bole, you can kind of see the Bryoria against the light a lot more easily than against the background of the tree. Now, the last metric relating to epiphytes that we have users identify is whether they saw any of the epiphytes that I previously described. If you saw any one of them in the stand, you'll say yes, that you saw an epiphyte. If you didn't see any of the above, you'll just say no. Now, the reason that we added this last variable is that when we were doing the modeling initially with the training data, we found that the presence of any one of the above epiphytes was more important than the presence of each one individually in predicting the late successional or old growth class of a stand. And this is not much more work because you will already have collected the previous 5. So once you've gone through, you just say if you saw any of these or you didn't. So now we've finished our rep, and here's our finished data sheet. Next, we'll show you how to input this data into the Shiny app back in the office. Once we're back in the office, we can now input these data into the classification algorithm to find out what kind of a stand we were just in. We have created a web page called the Shiny app to allow users to access this algorithm. I'm going to show you what that Shiny app looks like and how you can use it to enter your data and figure out the LSOG class of the stands that you conducted the RAP on. So here's what the Shiny app web page looks like. You can find a link for this web page in our RAP manual and also in the description of this video. So this web page is pretty simple. There's 3 tabs up at the top. The first of these is just an about page where we'll post any updates to this. This is a living document. And as we collect more data, we'll add to the algorithm to make it better over time. So we'll be posting any updates here. We'll link you to any newer versions as well. So if you see here and there's a link to a newer version, click that and use that instead. You'll also find here links to the most recent RAP manual, as well as some explanations of how to enter your data. It's very simple. There's 2 ways to enter data. The first is manual data entry, where users can enter one plot at a time using drop-down menus. And the second is for users who might have a lot of data, where doing that one by one would be time intensive. So you can put all of your data into a spreadsheet and upload the spreadsheet, and the results will also come out in a table. I'm going to walk you through both of these, and I'll start with the manual data entry. So this is what the manual data entry page looks like. We'll see here all of the 17 metrics we collected in the field, and they're broken down by forest structure, harvest history, and indicator epiphytes. I'll show you how to go through this data and upload what we just collected in the field to this page. So the first variable we see is tree fall gaps. We saw those in the big read plot, so we'll say yes. Pit and mound topography we also had. We saw recruitment in the understory of overstory species. We saw live trees with broken out tops. We tallied over greater than 20 big trees over 40 centimeters. We saw 6 to 10 40 centimeter standing dead trees. We saw 11 to 20 large down logs. Now for the harvest history, we saw no sawn stumps. We saw no skid trails. We saw no stump sprouts, and we saw no shade intolerant tree species in the overstory. The epiphytes, we had almost all of them. We had Liberia pulmonaria, Liberia corcuzans, Necra pinnata, Perella. We didn't have Bryoria, and we saw more than, or at least one of these epiphytes. So we can say that we did see one of the LSOG indicator epiphytes. Now we've entered all of our data, and all we have to do is click submit. Now that we've submitted the data, we can see here in the bottom left of the screen the model output. I've zoomed in on it here so we can see it a little bigger. So the most important result is on the left here, and it's the prediction. This is the most likely class of this survey we just submitted according to the model. And in this case, it says that the most likely class was old growth, and that is correct. We're in big read. We also see here a breakdown of likelihood by class. So this tells you the most likely class, as we already saw, was old growth with a likelihood of 66%. The second most likely class was LS with a likelihood of 34%. And the other two classes, transitioning LS and not LS, had a 0% chance of being the correct class for this stand. If you want more information on how the model works, you can see the appendix of the RAP manual, and we explain how we built the model and how it works. Now I'll walk you through how to enter data using the batch data entry method. Now for this method, you need to enter the data in a very specific way. The algorithm that we've written needs to have a certain set of column names, column order, and cell values. And to make that easy, we've built a template in an Excel spreadsheet that you can download that gives drop-down menus for acceptable values. I'm going to walk you through how to use this Excel spreadsheet to input your data and then input that data into the RAP algorithm. So to navigate to this Excel spreadsheet, you can go to the About page, and this link here, click that. That'll take you to a Google Sheet with all of the formatting that you need to use. Here we see 10 example plots to just give you an idea of what this looks like. Each plot is a row of data, so you input them lengthwise. For each plot, we'll ask you for a plot ID so that you can keep track of which plot is which. If you've got many plots, you'll need some kind of system to keep track of that. You can include latitude and longitude for your needs, but you don't need to for the model. And next we have the 17 metrics here. For these 17 metrics, you'll have an option of the drop-down acceptable values. So click one of these for each of the metrics. Now to enter your data, you won't be able to edit it on this scene, so you'll need to first download this as an Excel file. To do that, navigate up to the top left under File, click Download, and then Microsoft Excel. Click that and download to where you want to download the file on your local computer. Okay. Once you've entered all of the values for your plots, what you'll need to do is save this as a .csv file. The way to do that is go up to File, navigate down to Save As, and then save this. It'll be in an Excel workbook format, and save it as a .csv file here. Click Save. After you've entered that data, onto your local copy of that file, you'll be able to navigate to the Batch Data Entry tab and then input your data using the Browse button here. I'm going to show you how to do that right now. Browse, you click the plot, you click the file that your plots are in, and click Submit. And now this will again show you by row being a plot, the model output for each of these plots. We see the plot name, latitude, longitude, the most likely predicted class. In this case, for the first plot, it's old growth. For the second plot, it's not LS. And then again, a breakdown of likelihood by LSOG class. If you got a lot of data, you can show number of plots on the screen and search for specific plots. I hope you understand now a little bit more about the rapid assessment protocol and how to use it and how to conduct it in the field. If you have any questions or comments, you can contact John and I. Our emails are below in the description of this video. If you have any lingering questions, you can also check through the Rapid Assessment Protocol manual, where we explain all of this in a lot more detail. With that, I'd like to thank you all for watching and hope to see you around.
I'm rolling, so you can action anytime.
I can action anytime. Okay.